Hello students, welcome to Virtual Chemistry. This is Dr. Padmaja. Hope all of you are doing well and please subscribe to my channel. Today we are going to discuss about a very important and a very easy trick, that is a trick to find double bond equivalence. So the other names are DBE stands for double bond equivalence. Here DBE means double bond equivalence. And it can be even called as RDA, that means ring and double bond equivalence. Ring double bond equivalence, you can say. So very important trick, students. I will give you a very simple formula to calculate double bond equivalence, and I will let you know what are the applications of this particular trick as well. So let us see what is the formula for double bond equivalence. Double bond equivalence, DBE stands for. So you need to know only formula of an organic molecule. If you know the formula, then you can apply this trick. So that is, you need to know number of carbons, hydrogens, and other atoms in that particular organic molecule. So dB is equal to number of carbon atoms minus number of hydrogen atoms divided by 2 plus number of nitrogens divided by 2 plus 1. So this is a simple equation, or you can say trick, that you can remember easily. So what's the equation to calculate double bond equivalence or ring and double bond equivalence, students? So even you can take this as RDEB. Okay, that is equal to C minus H by 2. Here C stands for number of carbon atoms. Number of carbon atoms. H is equal to number of hydrogen and any halogen atoms. X means halogen, like fluorine, chlorine, bromine, iodine. If they are present, you have to count them. So halogen atoms, and N is number of nitrogen atoms. N is equal to number of nitrogen atoms. So if you know all this formula and how many atoms are present in that, simply can calculate double bond equivalence. Let us see with the details, with the explanation. So what are the uses of DBE? So let us see. First, what is DBE stands for? One double bond equivalence is equal to one double bond. It indicates one double bond. If you got the value as 1, then it says one double bond or one ring may be present in that. Similarly, if two double bond equivalents have come, then that is equal to, there may be two double bonds in that structure. Okay, or two rings may be there, or two double bond equivalence is equal to one triple bond, students. It may be representing one triple bond, remember. Okay, so in that way you can guess even one double bond and one ring may be present, one double bond and one ring. So depending on that, you have to choose in this way. So one double bond equivalent, if you got one value, dB is equal to 1, that indicates either one double bond is present in that particular organic molecule or one ring may be present. And if you got the dB value 2, that indicates two double bonds or two rings, or one triple bond or one ring and one double bond. Now let us discuss with example, students. I will give example for each. Now first example, take C3H6. Now calculate DBE for this. Double bond equivalence is equal to number of carbons are 3 minus number of hydrogens. We don't have any halogens, so 6 hydrogens divided by 2. Is there any nitrogen? No nitrogen. So plus 0 plus 1. That is equal to 3 minus 3 is 0, only 1. That means write the possible structures. So what are the application of DBE, students? Mainly we can write the different possible structures. So where we are using particularly this concept, application, where we are using, students, in identifying structural isomers. Identification of structural isomers. Structural isomers. So you can easily guess the structural isomers with the help of DBE, first application. Second one, you can say saturated or unsaturated compounds. You can differentiate whether the given compound is saturated or unsaturated. You can say the strength of the bond. If there are double or triple bond, so strength of the bond can be explained with the help of DBE. If it is only having single bond, you can break the bonds easily. If it is having double bond, so what is the strength of the bond, students? Triple bond is stronger than double bond followed by single bond. So because in order to break, in this case, you need to break 3 bonds. Here only 2 bonds, here single bond. So these are all the applications of DBE. Clear? So now tell me what are the structures of this one. Only one we got, that means it may be present one double bond or one ring. So try to write the structure, students, here. So one double bond, right? CH3, okay, CH double bond CH2. Can I write like this? Or you can say in a reverse way also same position will come here, CH2 double bond CH3. So this is one possible structure, students. See, 3 plus 1, 4, 4 plus 2, 6 hydrogens, 3 carbons. Okay, so one more way is what here, see, one double bond is present. You can even write a ring structure. See now, CH2, CH2, CH2. Total 3 carbons, 6 hydrogens. So this is the second possible structure of C3H6. 2 possible structural isomers are there. Okay, similarly, let us see one more example. Second example I'm going to give you here. That is take a ring compound, students. C6H6. Calculate DBE for this. Double bond equivalence is equal to C minus H by 2 plus N by 2 plus 1. Substitute the values. C is equal to 6 minus hydrogens. We have 6 hydrogens, 6 by 2 plus no nitrogens. So this value is 0 plus 1. 6 minus 3. Okay, 3. 3 plus 1, 4. That means what? In this, if you see C6H6, we know benzene. That means it is having one ring and 3 double bonds. 3 double bonds. Okay, so you can write the structure. See, one ring and 3 double bonds. Is it clear, students? So in this way, whatever the example they gave you in the exam, you can easily guess whether it is saturated, unsaturated, or having double bond or triple bond. Now let us say, I gave a compound like a C5H10. So find whether it is a saturated or unsaturated compound. Simply use DBE. DBE is equal to C5 minus H by 2 plus 0 plus 1, no nitrogens. 5 minus 5, 0. So double bond equivalence, only one I got. That means, is it a saturated or unsaturated compound, students? So you can say it may be unsaturated or it may be a ring compound. So unsaturated, even if it is having a ring also, it is said to be unsaturated. Okay, unsaturated compound. Simply you can say unsaturated. If you got DB is 0, then it is saturated. One more example, students. I gave you a compound C4H10. So now calculate DBE. DB is equal to 4 minus 10 by 2 plus 0 plus 1. So that is equal to 4 plus 1, 5, 5 minus 5, 0. That means here no double bond or no ring. So it is a saturated compound. It is a saturated compound. In that way, you can say even saturation as well. Okay, one more last example with a triple bond I will show you. So take fifth example, that is, the simple alkyne. Okay, C2H2. What is this, student? Acetylene. So acetylene. Okay. Now find DBE. DB is equal to 2 minus 2 by 1 plus 0, sorry, 2 by 2 plus 0 plus 1. So the 2 minus 1 is 1, 1 plus 1 is equal to 2. Now that means what? There may be two double bonds. 2 indicates two double bonds, or you have to guess in this way. Two double bonds or one ring may be, sorry, two rings may be present, or one triple bond may be present. Okay, now guess. So is it possible to write two double bond? Here only two carbons we have. How can we write two double bonds? We can't write. What is it possible to write the ring? In order to write a ring structure, minimum we need 3 carbons. Okay, here only 2 carbons are there. The only thing that we can write is a triple bond. So DBE2 means 1 triple bond. So in this case, the correct structure is this one. In this way, you can explain the nature of organic compounds. You can write the structural isomers. You can say the stability and possibility, dissociation energy, how much strength, energy they need to break the bonds, all these things, students. Hope you understood this topic. Definitely, it will help you to solve many questions related to this topic. Thank you for watching. Please subscribe to my channel if you like this video.